In this video, we are going to focus on rotations on the XY coordinate plane. And this is the typical problem that you might see on your homework or on a quiz, where you are asked to rotate a figure, in this case triangle ABC, 90 degrees clockwise, and in this case we're rotating about the origin. So you can see I have a green dot indicating that we are going to rotate about this point. When you do these, I think the easiest thing to do is to focus on one point at a time. So we're going to start out by focusing on point A as in apple, and I'm going to isolate that, and I'm going to show you how I like to do this, and then I'm going to review the intuition as to why I did what I did, and then we're going to follow with several more examples. So the first thing I like to do is, again, confirm what we're doing. So we're going to go 90 degrees in the clockwise direction. So this point is going to be rotated this way. So what I like to do is draw a line from the point of rotation to the point that we're working on. This is not always going to be the origin. It could be another point around which we're rotating, in which case you would draw this line to that point. But here we're going to the origin, so the first thing I like to do is draw this line. The next thing I like to do is to create a 90-degree angle right here. And that 90-degree angle is created because indeed we are rotating 90 degrees. Now, the next thing I do is I identify where point A is going to end up. The point after it's rotated, so we'll call that A prime. So A prime is clearly going to be in this quadrant, which we know to be quadrant 4. Recall the quadrants are labeled as such: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And in quadrant 4, the x value has to be positive and the y value has to be negative. So I know that the final x coordinate of A prime is going to be positive and the final y coordinate has to be negative. Otherwise it would not be in quadrant 4. The next thing I do is I take the values in the original point, point A, and I switch them. So the original x value becomes the new y value. Okay, so that didn't go very well, so I'm just going to write it in. 3 goes here, and 5 goes here. In other words, these are switched, and that is your final point. And then you would proceed to do the same thing for points B and C, and eventually you would create your triangle. So let's talk about why I was able to do what I did. Specifically, let's talk about why when you're doing a 90-degree rotation, you flip the x and the y just like we did. Okay, let's look at a 90-degree rotation. Okay. When you have a 90-degree rotation, initially your x-axis is associated with the horizontal. But when you rotate 90 degrees, and it doesn't matter whether you go 90 degrees clockwise, like this arrow is showing, or counterclockwise, the x-axis is now vertical. X was originally horizontal, now it's vertical. Similarly, if you look at the y-axis before the rotation, before your 90-degree rotation, the y-axis is vertical, and when you rotate 90 degrees, the new y-axis becomes horizontal. That is why you switch these numbers. This is why you switch the values. So whenever you're rotating 90 degrees, this value comes here in the new point, and the y value comes here. They flip-flop. And the reason they flip-flop is what was original a vertical axis is now horizontal, and what was originally a horizontal axis is now vertical. Okay, so to review, if you're dealing with a 90-degree rotation, these values flip. Folks, I want you to ignore the signs in the beginning. Just look at the integers and flip them. Then, when we determine what quadrant you end up in, we apply the signs of the quadrant. So here in this first example, we had a point 5,3 here. We drew our line to the origin. We created a 90-degree angle, and we decided we had to end up in quadrant 4, and then we just add these signs to these digits. Okay, let's do another example. Whoops. Okay, so in this example, we're asked to move this point via rotation 90 degrees counterclockwise. So let's plot our point. We start out as -3, 2. That would put us over here. Now, we draw our line to the origin. We're going to go 90 degrees counterclockwise. So counterclockwise is going to be in this direction. So we know that there's going to be a 90-degree angle created, and we know we're going to end up in quadrant 3. Okay, what's our first move? Our first move is to flip these because we have a 90-degree rotation. So our new point is going to be 2, 3. We don't worry about the signs yet. We just focus on the absolute value, if you will. Then we ask ourselves, okay, the x value in quadrant 3 has to be negative, so we make that negative, and the y value has to be negative, so we make that negative. Folks, this is your final point. So if this was A, this would be A prime. 90-degree rotation. Flip the positions of the number itself, the integer itself. Ignore the signs and deal with the signs at the very end when you determine which quadrant you are in. So this is a 90-degree counterclockwise direction rotation. Next, we are going to consider the 180-degree rotation, and we're going to use this point as an example. And we're going to go counterclockwise as indicated here. Now note, folks, that you might see counterclockwise depicted as positive 180. And that's because by convention, when we go counterclockwise, that's considered positive. Imagine, for example, someone asks you to draw a 30-degree angle. What you would do is you would draw that 30-degree angle here, like so. So by convention, again, positive is counterclockwise. So you might see this as capital R for rotation, positive 180. So let's look at the intuition of a 180-degree rotation, and we're going to use clockwise for this example. If we had the initial axes with y on the vertical and x on the horizontal, and we rotate these axes 180 degrees, you can see the x is going to end up here, and the y is going to end up here, which is depicted on the right. So notice, the x-axis is still horizontal. The y-axis is still vertical after this 180-degree turn. As a result, when you do rotations where 180 degrees is involved, there is no flip of the x and y integer. And we will deal with the signs later when we determine where the final quadrant is. So if you see at 180 degrees, you keep the integers in their original location, and then you deal with the sign when you determine the final quadrant. Note, 180 degrees counterclockwise and clockwise is the same. So as soon as you see 180 degrees, you keep the location of the integers the same. Okay, so let's go back to our example, and we have a point here which starts out in the fourth quadrant. And as before, we are going to draw a line from the point of rotation, which in this case again is the origin, and now we are going to create an angle that's 180 degrees from that original line. If you go counterclockwise, which again is considered in the positive direction, or if you go clockwise, which is considered negative, you're still going to end up in the same place, so it doesn't matter. So as we spoke about a few moments ago, because we are doing a 180 degree rotation, we keep these integers the same. Okay, we don't talk about the sign yet. Okay, so that's going to become 5, 3. Now let's look at the sign. We went from this original spot, let's call this point A, to A prime. We are now in quadrant 2. When you're in quadrant 2, the x value has to be negative and the y value has to be positive. So our final point is going to be -5, +3, as determined by the signs in this quadrant. Let's now look at the 270 degree rotation, and let's look at how to rotate this point, -3, +4, 270 degrees counterclockwise, which recall that is positive in the convention. So let's first look at the intuition of a 270 degree rotation. If we draw this line and we rotate it counterclockwise, again that is considered positive, 270 degrees we would end up in this location. But notice, if we were to rotate 90 degrees clockwise, okay, that would be negative in the convention. We would end up in the same location. So a 270 degree rotation this way is the same as a 90 degree rotation this way. So as a result, you can think of a rotation of 270 degrees as a rotation of 90 degrees in disguise. And as a result, the 90 degree rotation rules apply. So if you have either a 270 degree or a 90 degree rotation, you are going to flip the positions. And again, we will deal with the sign later once we determine the final quadrant. So let's look back at the example that we were considering, and let's see what happens. Let's first plot our point. And since we are at -3, +4, we would be in this location. We draw our line from the point that we are rotating to the point of rotation. Again, in this case, it is the origin. This rotation calls for a 270 degrees counterclockwise rotation. So that would mean we would rotate it 270 degrees this way. But instead, we are going to go 90 degrees clockwise. So if I create a 90 degree angle here, we are going to end up in quadrant 1. So let's get our final point. We flip the integers. Again, when we do our flip, I'm only looking at the integers themselves. I'm not concerned about the sign until I evaluate what quadrant we end up in. We're in quadrant 1. Both the x and y values in quadrant 1 are positive, and as a result, that is our final answer. Let's look at another 270 degree rotation. Here, we are at -2, -5, which would bring us here. We draw a line from the origin to the point that we are rotating. Here, we are calling for a 270 rotation clockwise, which would be this way, and that is considered negative by convention. So instead of going 270 degrees clockwise, we are going to go 90 degrees counterclockwise. So let's create a 90 degree angle between those two lines as such. We're going to end up in quadrant 4. Our final point, we are going to flip the integers. We are not even going to consider the signs. We are only focusing on the integers, and we're going to flip their position. And we know that in quadrant 4, we have to have a positive x value and a negative y value. So our final point for this rotation is going to be positive 5, negative 2. Let's end with a few examples, and we're going to go through these quickly. We have a point positive 3, positive 4, that puts us in this area. A 90 degrees clockwise rotation. So we're going to connect to the origin. We're going to draw a line that will give us a 90-degree rotation clockwise, and that puts us in quadrant 4. Because this is 90 degrees, we're going to flip the location of the integers. We're not going to look at the sign until the very end. Now we're in the fourth quadrant. In the fourth quadrant, the x value is positive and the y value is negative. That is our final point. Here we have a 270-degree counterclockwise rotation. Let's plot our point. We are at negative 2, positive 3, puts us in quadrant 2. A 270-degree counterclockwise rotation would be in this direction, but instead we are going to do a 90-degree rotation clockwise. That puts us in quadrant 1. Remember, a 270-degree rotation is a hidden 90-degree rotation. Because it is 90 degrees, we are going to flip the location of the integers. We're going to take 2 and put it here. We're going to take 3 and put it here. Now we're going to address what signs there will be. Because we are in quadrant 1, they both have to be positive. That is your final point. One more. We have this 180-degree clockwise rotation. We literally can erase this because it doesn't matter what direction we go in. Let's plot our point. Positive 7, negative 4 puts us in quadrant 4 to start. Let's draw the line to the point of rotation, which is the origin. Let's draw another line which will create the 180-degree rotation. Again, it doesn't matter which way you go. You still are going to end up in the same location, which is quadrant 2. Because this is a 180-degree rotation, we are not going to flip the location of the integers. We're going to first write down the integer itself. We're not even going to worry about the signs. Now, when we know we end up in quadrant 2, the x value has to be negative and the y value has to be positive, and as a result, that is our final point.